Hi everyone, this is Chuck McLennan. Welcome to another Buick Know-How. This month we'll spotlight the 1995 Roadmaster. We've been invited to hear from the largest group of Roadmaster experts around, the men and women who build them here in Arlington, Texas.
Hi, Chuck. On behalf of everyone here, I'd like to welcome you to the Arlington Assembly Plant. Welcome to Texas.
Well, thanks very much. This is just an incredible facility. It's huge. So where are we standing right now? Is this the final assembly area?
Chuck, this is the final quality checkpoint. If we find anything wrong with the car, we'll spot it here and take care of it. We want these cars to be as problem-free as we can possibly make them. The initial customer surveys we get back tell us that Roadmaster is doing better than ever in 1995. These surveys tell us we're doing the right things here, but there's a lot more to our story. It takes hundreds of steps to build Roadmasters. Every operation has to be within the intended design specification. We rely on everyone's eye for detail to help make sure each 1995 Roadmaster is a high-quality product. We've made some great strides in quality, and it's really paying off for us in 1995. This plant is working hard to produce a quality product.
Well, you have to be happy about that. Max, I can't thank you enough for allowing us into this facility.
My pleasure, Chuck.
Thanks. I'd like to begin by introducing Ron Holcomb. Ron is a wind noise engineering specialist. Hi, Ron.
Hi, Chuck. It's good to have you here in the plant. We've got a lot of things we'd like to show you today, so I guess we ought to get right to it.
Good, let's do it.
About 2 years ago, we developed a static wind noise check for our vehicles. A static check is a visual inspection on a stationary vehicle that concentrates on key characteristics known to impact wind noise or wind rush. Our static checks have been correlated with data collected from actual wind tunnel tests. After incorporating the tunnel data, we know which assembly operations are most likely to generate customer complaints. These critical operations are monitored and results are presented to the plant on a daily basis. We then determine what kind of corrective action is needed. I'd like to begin with a brief explanation of terms because some people may not know the difference between wind noise and wind rush. There are two types of wind conditions, wind rush and wind noise. Wind rush is an external condition. It's the sound of outside air racing and bending around the exterior surface of a car in motion. The sound of wind rush increases as it deflects around a side view mirror protruding from the smooth silhouette of a vehicle. A misaligned body panel can also cause wind rush. While some wind rush is correctable, a certain degree of it is normal. Wind noise is an internal condition caused by unequal air pressure. The outside air rushing past the car creates a vacuum or area of low pressure. However, because air continually enters the passenger compartment through heating and air conditioning ducts, a high interior air pressure exists. This high pressure exists whenever the blower is on. The high pressure air seeks equalization by escaping to the low pressure area just outside the car. Normally the escape routes are through the pressure relief valves and the door jambs. However, if this interior air also escapes through faulty seals, wind noise results. It typically has a telltale, high-pitched whistling sound. As a general rule in wind noise diagnosis, and this is important, after evaluating the owner's primary complaint and correcting that area, You should also listen for any secondary conditions that may only become noticeable after the primary condition has been eliminated. By treating these secondary conditions, you can spare your customer the aggravation of returning with a wind noise problem. At this point, I'd like to introduce you to John Richardson and Kenny Kirkland. Both are wind noise technicians here in Arlington and often work with dealerships on customer complaint vehicles. John and Ken will now step you through the static audit items and will offer other helpful tips. John, how about starting us with the windshield upper reveal molding?
No problem, Ron. What you need to look for is continuous contact between the sealing lips of the upper windshield reveal molding and the glass in front, and also to the roof at the rear. Any gap in this area creates a great deal of wind rush. This is one area that has been under control for some time. You shouldn't see many 94 or 95 Roadmasters with this problem, but if you do, this is how to take care of it. First, check for proper alignment at the upper windshield reveal molding to the roof and the glass. The molding must lie flush to both the roof and the windshield. If you have a gap at the windshield upper reveal to the roof that is less than 2 millimeters, loosen and partially remove both the right and left auxiliary weather strips. Tape off both the upper reveal moldings and the roof panel to prevent excess accumulation of sealer. Next, carefully backfill the gap with RTV sealant. Clean any excess with sealant remover. If the gap is more than 2 millimeters, remove the side reveal moldings. Grasp the end of the upper windshield reveal molding. Rotate it gently forward while pulling it from its cavity. If you damage this molding while removing it, you will need a new molding. You will need to trim the lower lip off the molding to install it without removing the glass. Next, dry fit the molding. Make sure it lies flush to the roof and the windshield without gaps. Remove the molding and clear out any leftover adhesive that may interfere with installation. Apply urethane, filling the cavity to the lower edge of the windshield. Finally, install the molding. Use masking tape to secure it to the roof overnight for proper curing. This procedure holds the molding in place while the urethane cures. The next morning, remove the tape and clean off any excess adhesive from the glass, molding, or roof. If the upper windshield reveal molding has a more extreme gap, check the position of the glass in the opening. It may be necessary to remove and reinstall the glass to eliminate the gap and quiet the area. The next area we need to talk about is the A-pillar windshield reveal moldings. Ken, would you take this one?
Okay, John, the A-pillar windshield reveal molding can cause wind rush if it gaps to the windshield glass or if it fails to make good contact to the door header. To eliminate wind rush, there must be continuous contact along the entire length of the A-pillar between the windshield side reveal molding and the door header on the outboard side. You also need to look for continuous contact between the molding and the glass on the inboard side. A 2 millimeter gap near the base of the A-pillar is acceptable as long as it's 50 millimeters or less in length. If a gap exists between the A-pillar side reveal molding and the glass, remove the molding and hold it flush to the glass. This will show you how much the screw holes in the molding frame will have to be modified to properly position the molding flush to the glass. Use a rat tail file to slot the screw holes as needed. Use RTV thumb grade or an equivalent sealant to close off the underside of the molding to prevent air turbulence under the molding. After performing this procedure, reinstall the molding and make sure the gapping condition has been eliminated. Check the opposite side of the car and repeat this procedure as required. Use thumb grade sealer to fill any gap between the top of the windshield side reveal molding and the windshield upper reveal molding. Remember, when reinstalling the auxiliary weather strip, make sure that the rubber is positioned correctly for cosmetic appearances. It's important that the primary seal does not become trapped by this auxiliary weather strip. If the molding fails to make good contact with the door header, it may be necessary to refit the door. At this point, I'd like to introduce Cliff Russell. Cliff is one of our body fit technicians and he'll tell you how to correct wind noise at the primary door seals.
Another source of wind noise could be the primary door seal. Before you do anything, you need to check the door primary seal for enough compression. There should be continuous contact between the primary seal and the door around the perimeter of the door openings. This can be checked by laying a dollar bill over the primary seal and then shutting the door to pinch the bill between the seal and the door. Now, when you try to pull the bill out, you should feel some resistance. If the bill pulls out easily, there is not enough seal compression to prevent a wind noise. Check 7 or 8 points around the perimeter of each door. All points must pass this test. Also, check to make sure the primary seal is fully seated on the pinch weld flange, especially in the corner of the door openings. The door must have a proper gap of about 4 to 6 millimeters between panels. The seal must have full contact around the door perimeter, but overcompression of the weather strip could increase the door closing effort. The powder test is another way to check the compression of the weather strip. First, apply masking tape to the door garnish molding to facilitate cleanup, and then apply tracing powder to the seal surface on the door. There should be a transfer of powder onto the primary seal where there is adequate compression. A board in the powder transfer identifies the wind noise path. Since this board is very localized, it may only be necessary to adjust the flange. If you have a door that looks good in the opening, but you still have a wind noise or a seal leak in the Pacific area, remove the primary weather strip and bend the pinch weld flange outboard to increase compression. Make sure to check closing effort and adjust the flange as necessary. You don't want to trade a wind noise for a hard closing effort. If you do need to move the door to obtain a good fit and proper weather strip compression, refer to the door fit procedures that are outlined in the Roadmaster service manual. Then, after you make your adjustment, check the door again to make certain the door still looks good in the opening and that the wind noise path has been eliminated. Now, John is going to cover the fender-to-body hinge pillar, wind rush concerns.
The next area you can look at is a hinge pillar. A foam rubber noise deadener is installed between the hinge pillar and the fender to stop wind rush from coming through the inner channel of the fender. If this piece is not positioned correctly, you might hear wind rush at the base of the A-pillar. Check both the upper and lower plastic noise deadener alignment. If these are mispositioned, you could get wind noise up through the A-pillar. Reposition it with a hook tool. Now let's talk about how to take care of an upper reveal molding to door gap. Look at the fit of the patch and the upper reveal gap fit to the door. We have created two defects on this door to illustrate conditions I'm going to describe. You need to be sure that there's no gap between the door sheet metal and the front edge of the mirror patch and the upper door reveal molding. A gap to the door sheet metal may be caused by weld distortion on the attaching flange, so you may have to remove the molding and straighten the flange. Slight gaps are acceptable in the mirror patch area as long as foam is visible in the gaps. If the gap at the mirror patch to the upper reveal is more than 3 millimeters, remove the door reveal molding and reposition it to close it up. Another wind rush source in this area can be caused by mismatch between the mirror and the reveal molding. There should be a smooth transition from the upper rear corner of the patch to the upper reveal molding at the point where the two parts join. If the upper reveal molding is outboard of the patch, a step is created which causes wind rush. To correct the step condition, at the upper reveal to the door patch area, you may have to remove the door pad. If so, reposition the mirror at the attachment screws. This will allow you to access the mirror patch and reposition it. And that should take care of it. Ken, would you like to tell them what to do about a wind noise at the run channel?
Sure, John. Wind noise complaints may be caused by a poor run channel fit to the door frame. To correct this, lower the front glass and pull the run channel down and outward from the door header frame. Remove the foam patch inside the upper rear corner of the door header. Fill the two cavities in the door frame with sealer. Install the foam patch back into the door header. Run a bead of bedding and glazing compound around the inboard edge of the retainer. Then spray the run channel with glass cleaner to ease installation back into the door header. Use a plastic trim stick to ensure that it fully seats in place. Perform this on any of the other doors if you suspect that they are contributing to wind noise. There are only 2 quick items left, so John, how about wrapping it up for us?
No problem. This is a real minor thing, but we found that wind rush can occur where the run channel overlaps the fixed glass. Let me show you what I mean. Inspect the fit of the rubber molding here. Pull back the small flap by the fixed glass at the top and load that void with thumb grade sealer. Then reposition the flap. That one was very easy. If there is a complaint about excessive road noise in the rear seat area, remove the air relief valve in the body lock pillar. Looking down inside the cavity, you'll see an open area or a hole at the base. Closing the hole with butyl tape may give a degree of improvement. Reinstall the air relief valve and reevaluate the complaint. Of course, always make sure the door primary seal is good at the rocker panel anytime noise complaints occur.
Guys, thanks a lot. It sure is great to get this kind of information from some real pros.
We've put a lot of effort in quieting these cars down. We appreciate the opportunity to show you this information.
Now I'd like to introduce another Roadmaster expert, Kathy Vitrone. Kathy is the water leak engineer here at Arlington. Hi, Kathy.
Hi, Chuck. I help improve the build process so that we can prevent water leaks. Now, I'm only one person. Out there on the floor, there are dozens of dedicated people doing their best to make sure these cars are built right. And frankly, we have made tremendous strides preventing water leaks. We work very hard on this car. We are trying to build a high-quality product, but we also know that sometimes a car needs special attention.
Water leaks are sometimes difficult to find and fix. It can be a very frustrating experience.
I know what you're saying, Chuck. However, if you allow me to show you a few techniques and hints, I believe it can be a lot less frustrating for the technician.
Okay, Kathy, show us some of these techniques.
First, let me say that these techniques will apply to any late model Roadmaster. Let's start with a B-pillar to roof water leak. If a customer has a leak at the top of the B-pillar, it could be caused by a metal mismatch, gap, or a spot weld pinhole in the B-pillar joint. Even though the welds are structurally sound, one tiny pinhole can cause a leak. The left side of the wagons have been our biggest problem. We started adding butyl tape at the beginning of April in 1995 to ensure a perfect seal. So if you want to check for a leak in this area on a car built before that, have an assistant run water on the top of the B-pillar area while you watch for a leak. I'd like to introduce Tim Webb. His job is to water test vehicles and root cause any problem. Production is notified if the leak exists, and we work back to the area where the problem originated. Tim will help me with this demonstration. First, he removes the auxiliary weather strip. Then he will dry the exposed seam. Inspect the flange for pinholes, gaps, or metal mismatch, and fill with thumb grade sealer or clear seam sealer. And finally, he will replace the auxiliary weather strip. As an extra precaution, technicians may choose to seal the entire roof rail with a length of butyl tape and even add a bead of clear seam sealer inside the weather strip itself. Let's move to the trunk area. We know that nobody wants wet luggage or groceries. If there's a leak here, of course, the carpet will be wet. A trunk water leak sometimes shows up due to a flange mismatch at the weather strip area. If the metal mismatch causes the flange to be spread open, the trunk weather strip can appear to be correct. However, the flange is holding the weather strip open, allowing water to enter the rear compartment. Use a block of wood and a hammer to flatten that flange. Beginning with the start of production 1995, our flanges are being monitored even closer. If any discrepancies are found, the entire system is checked and reworked. Also, as of April 24, 1995, VIN number 422343, we started installing a weather strip with a foam adhesive inside. The part number is 10279816. This new weather strip can be used in place of the old style part. If the flange is bent downward and causes the weather strip to drop too low in the corners, we adjust that with this special Teflon fork tool. A technician must be very careful when adjusting the flange. Another area where leaks have been seen is in the TULIP panel. If a leak is found, reseal the body metal seam at the end of the TULIP panel with clear seam sealer. Using a clear sealer eliminates any need to paint. Since the start of 1995 build, we are applying patches in this area which has stopped potential leaks. While we are in that trunk area, I want to talk about the backlight water leaks. This is caused by a metal mismatch that leaves a gap or by a weld that causes the metal to have a ripple at the weld joint. The leak occurs because the backlight does not squeeze the sealant into the ripple, leaving a hole. This water leak is repaired by pumping urethane sealer right into the void. It is important to remember that anytime you use urethane, the metal must be primed to guarantee bonding. Run water in this area to verify the leak and also the fix. On the estate wagon, a customer may complain of water or a sloshing noise in the spare tire compartment. The compartment may have water in it. If there's a gap in the last few inches of the ENDGATE weather strip, water can seep behind the weather strip. But if you look closer, you can see we have 4 layers of sheet metal spot welded together. In extreme conditions, water can seep in through the metal layers and ends up in the spare tire compartment. Water could collect here if the drain hole is plugged. Seal the 4 layers of spot welded seam with thumb grade sealer and then apply butyl tape. We started applying sealer to make the transition smoother in February of 1995, then reinstall the ENDGATE weather strip. If water has entered the left rear side storage compartment, it may have come from the hinge area. At ENDGATE installation, some adjustment is necessary for a proper fit. These square hinge holes are normally covered, but if the ENDGATE exposes even the smallest fraction of the square hinge hole, water may leak in. If water is in the left rear side storage compartment, inspect the ENDGATE hinges for gaps. If you cannot see a gap, run water on the lower hinge first, watching for leaks. If that is okay, run water on the upper hinge. That tells you which one to seal.
The know-how manual contains information on other water leak concerns. Now, we're going to talk about squeaks and rattles. Kathy is Arlington's engineering expert for squeaks and rattles as well.
Well, you know, Chuck, the squeak and rattle part of my job sometimes gives me clues to water leaks. For example, a backlight squeak can also be a water leak. Both could be caused by a void in the backlight urethane. So remember to use all your knowledge when diagnosing the root cause of a concern. This theory can also be applied to wind noise and water leaks as well. Frank Jessic and Morris Himes are my noise busters. Frank will be assisting me today. Our Noise Buster team believes that a customer's perception of his Roadmaster can be drastically reduced by even one squeak or rattle, even if the car is perfect in every other area. Our customers tell us that their biggest noise complaint comes from the instrument panel as the car is driven on a rough road.
Aren't instrument panel noises difficult to locate?
Well, not really. Once you know where to look, it can be relatively easy. Let's start with the noise caused by the instrument panel brace rattling on the stud mount. The rattle gives the perception that the center of the instrument panel is loose. First, remove the instrument topper pad. Slip a 1-inch length of rubber hose over the stud to provide a cushion for the crossbar brace. Then, reinstall the topper pad. Now let's move on to the doors. Customers may comment on a clanging noise when the front door is closed. When the door is slammed shut, the window regulator motor could vibrate against the door inner sheet metal, producing a clang. Our supplier is now taking care of that by placing a foam patch on the motor. As long as the patch is adhered to the motor in this location, the motor will be isolated from the inner pad. If the noise still exists, you may want to apply a larger piece of foam between the regulator motor and the inner side of the door panel. Let's go on to the rear door rattles. Customers may report hearing a rattle when the rear door is closed. The cause of this rattle is the forward lower glass run channel hitting the upper channel. Beginning with start of production for 95, we have been installing the channel with its lower screw pushed forward in the slot and the upper screw rearward in the hole. As long as you're inside the car with the trim pad off, check for any other rattles that may be repaired by tightening a fastener or removing loose material in the door. Also check the rear glass run channel to assure that the glass is properly seated in the channel. This next noise could be found only on estate wagon second seats. If the lock mechanism and the striker are not perfectly positioned, you will hear a noise when you put your weight against the seat back. The striker must be loosened to be adjusted. Lower the seat back so that the striker just barely clears the trim plate. Then retighten the fasteners. The next area we focused attention on is the end gate, where a tuning fork type noise was heard when closing the end gate. Adding foam blocks restricts the movement of the parts in this area, which is essential for solid sounding door. The end gate window latch release solenoid used to vibrate when the end gate was closed. So mid-1994, we started supporting the solenoid with a block of styrofoam to eliminate the vibration. Also, a rattling noise occurred because the rod was free to move in its clips. At the same time, we added 2 pieces of foam to the end gate. If you see that this foam needs repositioning, be sure to place it correctly, like this one. And that's how we get a quiet end gate.
This is great stuff, Kathy, but tell me, what would you think a technician would find to be a really difficult to diagnose noise?
Well, a tough one would be the windshield reveal or the A-pillar itch. It's most noticeable on rough roads in cold weather. However, it can happen at any time. The customer may report this as an instrument panel noise because of the way the sound travels down the pillar, but it's actually a squeak between the glass and the reveal molding. To verify the problem, drive the car on a rough road and in cold weather if possible. To fix the noise, apply a small amount of lubricant along the windshield and the A-pillar as Frank is showing.
Kathy, sometimes we hear about a driver's door sticking to the weather strip. That can make the door hard to open.
Well, the weather strips are very soft and pliable, so they will easily conform to the shape of the door header. So, on some cars, the rubber and the door sheet metal may tend to stick. If you hear a sticking or a zipping noise when you open the door, spray lubricant on a cloth and wipe it over the weather strip.
This is all great stuff, Kathy. The Roadmaster I drove here was very quiet, not a rattle to be heard. Proof to me, at least, that everyone here is really buckling down for quality.
Well, Chuck, I know a lot of people out there, and they really are building quality into these cars. That's what I'm proud of.
Well, thanks very much, Kathy. You've been a great help to about 12,000 Buick dealership technicians. But don't go away. You'll want to catch Roadmaster Service Concerns Part 2.